Good day everyone. I am Lucero, a first-year BSIT student of Catanduanes State University, and I am here to demonstrate the AND logic gates by building a circuit using a digital tree. And here are the things needed to build a circuit. First is a digital trainer. A digital trainer is similar to a breadboard, but it has more controls and functions, and it comes with its own power plug that can be easily plugged into a nearby outlet, all in one portable and compact kit package. Second, we need a LED bulb for the output and at least 5 or more short solid core wires with exposed copper on its end. And last but not the least is the 7408 integrated circuit. This integrated circuit is responsible for the AND gate we are about to use in this demonstration. Before we proceed, we must first understand the tools and materials we are about to use. This is the main diagram of the AND gate circuit we are aiming to achieve. The 1 and 2 are input gates, and the number 1 inside the shape is the value of output, which is the number 3 of the 2 input gates. 1 means true, so in this example, the LED lights up. The lines here at the end is the ground, which closes the circuit. Now, we must familiarize ourselves with the digital trainer. These are the parts of the digital trainer. In this demonstration, we will mostly be using the experiment area along the power switch. The experiment area consists of breadboards. It is a board for making an experimental model of an electronic circuit. Here are the parts of the breadboard. Now, here is the diagram of the 7408 AND gate integrated circuit. The notch is a guide of the orientation of the integrated circuit that helps us locate where pins are. Pin 14 connects to the positive side on the power rails of the breadboard. Pin 7 connects the negative side on the power rails of the breadboard. Pin 1, 2, 4, 5, 13, 12, 10, and 9 are input terminals and are given value either positive or negative. Pins 3, 6, 11, and 8 are output terminals that produces the value of the two respective input terminals depending on the logic, which in this case is AND. In this demonstration, we will only be using pin 14 and 7 for the power, pin 1 and 2 for input, and pin 3 for the output. With all that in mind, let's start building our circuit. Here are the steps on building the circuit. First, on the experiment area, place the 7408 integrated circuit on the DIP support of the breadboard with its pins pressed on the left and right terminal strips. Please be mindful of the direction of the notch because we might confuse ourselves which pin is which. Second, we place the tip of a wire to a hole next to pin 14 and its opposite end to a positive hole on the right power rails. Then, we place the tip of another wire to a hole next to pin 7 and its opposite end to a negative hole on the left power rails. Step 3. Placing the LED. Place the positive side of the LED, which is the longer side, to a hole on the terminal strip, preferably a few holes below the integrated circuit. Then place the negative side on the LED, which is the shorter side, to a negative hole on the power rails. Fourth step, place the tip of a wire to a hole next to a positive side of the LED, then place its opposite end to a hole next to pin 3. Remember, on the diagram, pin 3 is an output terminal. And lastly, Place a tip of a wire to a hole next to pin 1. Place a tip of another wire to a hole next to pin 2. Remember on the diagram that pin 1 and pin 2 are the input terminals. Let's come now to the demonstration of the logic of the AND gate in our circuit. First, here's the truth table for our AND gate circuit. 1 is true and positive, 0 is false and negative. Output 0 equals LED is off. Output 1 equals LED is on. In this truth table of AND, if pin 1 is 0 and pin 2 is 0, then pin 3 is 0. If pin 1 is 0 and pin 2 is 1, then pin 3 is 0. If pin 1 is 1 and pin 2 is 0, then pin 3 is 0. And if pin 1 is 1 and pin 2 is 1, then pin 3 is 1. The condition of the AND logic is that only if the two inputs are 1 and the output can be 1 and the LED lights on. Let us now plug in the digital trainer to an outlet and turn on the power switch. If the switch lights up, the circuit is correct. If not, please check the circuit for the errors. For the first logic, pin 1 is 0 and pin 2 is 0. Let's connect the tip of the wire to the pin 1 to a negative hole on the left power rails. This indicates that the truth value input to pin 1 is 0 or false. Now, let's connect the tip of the wire of pin 2 to another negative hole on the left power rails. This indicates that the truth value input to pin 2 is also 0 or false. Therefore, according to AND logic or the truth table, if pin 1 is 0 and pin 2 is 0, pin 3, which is the output, will also be 0 and the LED will not turn on. For the second logic, the wire of pin 1 will not be moved and pin 1 will remain 0. We connect the tip of the wire of pin 2 to a positive hole on the left power rails, indicating that pin 1 is 0, which is false, and pin 2 is 1, which is true. According to the truth table, the output would still be 0 or false and the LED will remain off. Now, for the third logic, we connect the wire of pin 1 to a positive hole on the left power rails, indicating that pin 1 is true. Then, we connect the wire of pin 2 to a negative hole, indicating to pin 2 is 0 or false. Then again, pin 1 being 1 and pin 2 being 0 by the truth table and logic, the output would still be 0, which is false, and the LED is still off. And lastly, we put each wire to pin 1 and pin 2 to each positive hole on the left power rails, indicating that pin 1 is 1 and pin 2 is 1, which are both true. Therefore, according to the truth table, the output would be 1 and true, which makes the LED light up. There, the LED lights up, proving that if pin 1 is true and pin 2 is true, then pin 3 is true or 1. And that's the demonstration for the AND logic gate through a circuit. Thank you all for watching.